Good day, Professor. This is Raymond Alaman, current student at GCU. This assignment pertains to Capture the Flag, Section 3, where we asked to make a video in regards to angr and pretty much everything we've discussed for coding. So first and foremost, angr is an open source binary analysis platform for Python. It combines both static and dynamic symbolic analysis, providing tools to solve a variety of tasks. However, angr does a lot of binary analysis. The most common angr operation is loading a binary, and this is known as p = angr dot project. Now, with reverse engineering, we can use it to construct models that describe the existing software, or even better analyze how something operates. Without the automation of angr, it will be more complicated to analyze data, as the whole purpose of automation is the use of technology to accomplish a task with as little human interaction as possible, which we know that in computing, automation is usually accomplished by a program, a script, or batch processing, such as the one we've done for this week. How to use reverse engineering. If there was no access to angr or any other type of automation tool, I would strongly collect the information. That would be like the first step in reverse engineering. And then I'll create a model or sketch. And then I'll begin to disassemble and make sure everything's correct, or at least looks right. Evaluate the product, and then reassemble. And again, that would be if I didn't have any other sort of automation tool such as angr. But with angr, it makes everything easier. Now, the key aspect is also that when we were running the a.out program, we were pretty much given a flag fail. But with the section 2 implementation and section 3 implementation, we were able to change that and capture the flag from a capture fail to a capture success. Moreover, that concludes portion for this assignment.